Good morning. I felt like being underwater today with an axolotl. Today, we are going to talk about bivariate relationships. That is, relationships between two variables. And we're to start with correlation. But even before that, we're going to plot out our data. Now, why plot your data? Well, let's look at some graphs and see what we can learn. The data we're looking at, you should always know something about the data you're looking at. This is a test of multiplication and division given to students at reservation schools in the Great Plains. So it's part of a bigger study, and I just pulled out a random subset of students from that. All the students in the sample took the test twice. They took a pretest. Some students received an intervention where they played educational games. Some didn't receive any special program, and then they all took a post-test. Now, this is a very suspicious scatter plot. You can see there's a strong linear relationship here, right? The lowest score on this variable was also the lowest score on the other variable. The highest score on this variable was also the highest score on the other variable. Why do I say it's suspicious? Because in real life, few things are often perfect. And if you get a perfect correlation, you should question it. Now, in this case, I made a mistake. Well, I did on purpose to show you for this course. The x-axis here is the number of answers they got correct, and the y-axis is the percent correct on the test. So, of course, they're perfectly correlated. Now, each of these dots represents an individual score on two variables. So this person right here got less than 5 answers correct, and they scored less than 20%. This person up here got 24 answers correct, just a little bit less than 25, and they scored 100%. So that's what each dot on a scatter plot is the person's score on one measure on the x-axis and on the other measure on the y-axis, and there's where we put that dot. A perfect linear relationship does not mean the values are the same, as you can see. This person received a 2 right and less than 20%. Clearly, it's not the same score. This person, as I said, got 24 correct. They got 100%. The relative scores, highest, lowest, will be the same, but not the value necessarily. You'll learn more about that when we get to z-scores. The values can be the same if they're measured on the same scale, but if they're measured on different scales, like number correct and percent correct, the values won't necessarily be the same. And that's just one of those things that people know, but then they forget. They say things like a perfect correlation means they scored the same on both measures, which is exactly true. It means their relative scores were the same on both measures. You can have one of 4 kinds of relationships. Well, maybe there's a few more, but there's 4 we're going to talk about today. You can have a positive linear relationship as one score increases, another increases. You can have a negative linear relationship as one variable increases, another decreases. It can be 0. There's no relationship at all between the variables. Or curvilinear. Those aren't nearly as common as one variable increases, the other increases to a point, and then it decreases. Let's take a look at each of those. What can you say about this plot? There are a few things that I can tell you right away looking at this graph. One is there is a linear relationship, and it's positive. You can see that as the scores on, so this is the pre-test and the post-test, and students who had higher scores on the pre-test tended to have higher scores in the post-test, which makes sense because they're probably not going to go backwards unless you're the worst teacher ever, right? The students who are doing well are probably going to do a little bit better, and the students who are doing worse hopefully will also do better, but there should be some positive linear correlation, and there is. So there's a relationship, it's linear, it's positive. I could see that, and so you can sometimes find interesting things looking at graphs, and this is one example of that. This one student did quite poorly on the pre-test, and then they did great on the post-test. I might want to look at them. Did they just have a bad day in the pretest? Did they decide to turn their attitude around and really study for the post-test? This student over here actually did worse on the post-test than they did on the pre-test. So they were about 80 here, and now they're somewhat less. I might take a look at that student. Some examples of positive linear relationships: years of education and income have a positive relationship. High school GPA and college GPA are quite positively related. Fortunately, undergraduate GPA and graduate GPA, well, they are positively related. I'm an exception to that. I was a terrible student as an undergrad. Went to more parties than I did classes, but turned it around. IQ scores and achievement test scores are positive related. Household income and reading achievement. More affluent parents tend to have children who are doing better. Participation in after school activities and high school graduation. Kids who are in after school sports, theater, chorus, all those things have a higher probability of graduating. Stop for a minute and think of your own positive linear relationship examples. I'm sure you could think of some. This will be on the quiz. Notice the scatter. This is why it's called a scatter plot. A linear relationship means scores tend to go up or down together, but normally some scores will be higher or lower on the second variable than the others. A positive, perfect relationship, like I showed in that first graph that you saw, is not the norm. Normally, you'll see a trend that people who did well on the pretest tend to do well on the post-test, but it's not a perfect relationship. Some examples of negative correlation: the severity of child neglect and academic achievement. Children who are more neglected at home, who are treated more poorly, tend to do worse in school. The number of days a student is absent is negative related GPA. More days they miss, worse their GPA. The percent of students receiving free lunch in the school, and that school's mean scores on state assessments are negatively related, that generally the more students that you have at the poverty level at your school, the worse the academic achievement on the mean of the school. And again, there's a scatter, right? It's not perfect. Curvilinear relationships are less common. One that is very well documented is the relationship between anxiety and performance. Generally speaking, if we have down here a measure of anxiety, and this is your performance. I used to teach sports psychology. There's a lot, I know that some of you coach sports. There's a lot of data on this, that if you don't care at all if you win the race, if you don't care at all if you win the wrestling match, then your performance is going to be pretty bad. Up to a point, performance gets better and then it starts to decline. You've all heard about those athletes that choked, right? That they just got so anxious and panicked that they couldn't think, they couldn't do right, they couldn't do whatever their sport was, and they made mistakes they wouldn't normally make. And this is the curvilinear relationship that you see between anxiety and performance in tests, but I think it's been more researched in sports. So get your students to calm down, but not too calm. Then there's things that there's no relationship. I looked at the relationship between how many people are in your family and how many people you consider family. And you could see this is pretty much a straight line. If I drew a line across here, it wouldn't be really going up or down. It would just be, don't make fun of my drawing. And if you remember from math, which math class, whatever year it was you had in high school, a straight line has a slope of 0. If the best fitting straight line to match all those scores is 0, is flat, a slope of 0, then that says that you have a 0 correlation. If your line is like this, if it has a positive slope, then you have a positive correlation. If it's going down, you have a negative slope, you have a negative correlation. But in this case, we have no relationship between the number of people you consider family and the number of, which is down here, and the number of people like family up there. And you could see we have one crazy outlier. That's what I have to say about scatter plots. We'll talk about computing correlation in another video.